The next force we're going to talk about, and I should have written that up on the board, but I'll do it right now, is tension. And not the kind of tension you can cut with a knife, even though you can cut this tension with a knife. Tension is a force that is much like a normal force. It responds. Once you've applied so much force on an object, its tension responds to that. When we're dealing with tension in this class, we're going to deal with a particular type of object. It doesn't mean that tension is only reserved for this type of object. We can deal with tension with other things, but when we're dealing with tension, we're going to talk only about strings. Okay? We are not going to talk about tension inside of a bar, let's say, which is very common. There is tension inside that bar. You can try to compress or kind of try to stretch that bar, and you're experiencing tension. Excuse me. When we're talking about tension, we're going to talk about tension that's inside of a string. Tension, if you look at it as a small scale item, you look inside of a string, and inside that string there are molecules that compose the string. The tension is felt in between these molecules. Okay, so in between those molecules you experience the force of tension. So here's my molecules, make them a little bigger. The tension is felt in between them. You're taking that thing and you're stretching it out, or you're trying to stretch it out, and the molecules are responding. They're feeling that pull apart. Okay, so that's tension. It's a responsive force. It always is responding to the amount of force that's applied pulling the string apart. Okay, it responds to that. It's also always in the direction of the string, not spring, string. It's always in the direction of the string. You never feel tension perpendicular to the string. It's always in the direction of the string. And also, when dealing with tension, tension is always equal inside the string. So if we take an object like a massive object, something that's experiencing gravity, and we take another object that's less massive, so this is big mass and this is little mass, the tension that's pulling up on this and the tension that's pulling up on that are identical. They don't change. As long as this is one string, the tension here and the tension here have to be the same. It's one of those properties. Okay? So tension is always equal across the entire string. It's felt in the direction of the string, and there is no equation for tension, which means that tension responds to forces. If I hang a rope and I hang a mass onto it, let's say the mass has a total, let's say 10 kilograms, so the weight of that object is 100 newtons. Then that means that the tension that's responding to the weight hanging onto it is also going to be 100 newtons. It's that responsive, much in the same way normal forces behave. Okay, so always the same and through the entire string, always in the direction of the string, and it responds to how much it needs to be. It grows or shrinks to whatever it needs to be. Okay, that's the force of tension.